Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Polynomials. Question 11, Binomial Expansion. Inbox me at nemedicine@gmail.com to order your complete Cram session. Question 11, Polynomials. Write out the expansion of 2x minus y raised to 4. Definitely press pause if you need to, and I'll give you a moment to think. All right, so this is of the form a plus b raised to the n, okay? Hence, it's a binomial raised to a power, and n in this case is the exponent 4. I said raised to a power, but I really meant raised to an exponent because in exponential expressions, the power is the actual result of the exponential equation, okay? So that's a minor correction that many people often interchange the expression power and exponents. It's actually a misnomer. All right, now that that's out the way, our a is represented by 2x. And if we change this minus sign into addition and distribute the negative to y, our b is negative y. Okay, so there's a formula for expanding a power of a binomial, and it's written here in summation notation. So it's going to be the summation from k equals 0 to n of n choose k times a raised to the n minus k times b raised to k. Okay, and k is just the term of interest because sometimes you're not interested in writing out the entire expansion. Or in combination theory and probability theory, it's the amount of elements that you're choosing from a set. Such as if you were to have a deck of cards, the n would be 52 because there's 52 individual cards in a deck. But let's say you were to choose a suit of spades or hearts or aces. A suit always contains 13 cards, so it could be 52 choose 13. Okay, so something like that. But here for our binomial expansion, it usually represents the term of interest. Let's say you're interested in the fourth term, second term, third term, etc. All right, and note here, everything is shifted down 1 because the first term is when k equals 0, not when k equals 1. So the first term is k equals 0, the second term is when k equals 1, and so forth. And you're going to see that in just a moment, okay? And this particular formula or function is contained in a graphing calculator. But let's say you're doing this all out by hand, which I don't recommend because it's very time consuming. This equates into a factorial equation that says n factorial over k factorial times n minus k factorial times a raised to the n minus k times b raised to the k is equivalent to this formula as well, okay? So this is just a substitute for the combination notation for when you're doing this out by hand. All right, so let's apply this equation to our binomial of interest. Again, n is equivalent to 4, a is equivalent to 2x, and b is equivalent to negative y. So our expansion is as such. The first term, when k is equal to 0, you have n choose 0 and 2x raised to the 4 minus 0 times negative y raised to 0. You have the second term when k is equal to 1, the third term when k is equivalent to 2, the fourth term when k is equivalent to 3, and the fifth term when k is equivalent to 4. And notice that for the a term, the powers of a, or the exponent that a is being raised to is descending, while the exponent that the b term is being raised to is ascending, okay? So that's just something to keep in mind. And because we're starting our expansion at k equals 0, a fourth order polynomial will have 5 terms. or a fourth order binomial expansion will have 5 terms, okay? So this is what the first term reduces to. So n, when you have 4 choose 0, anything choose 0 is always going to be 1, all right? So yeah, that's usually what it boils down to. And then you have 2x raised to the 4th power times negative y to the 0. And we know that any base raised to the 0 power is also 1. So that corresponds here, and this looks correct. This is our second term. This is what our third term simplifies to, our fourth term simplification, and the last term, okay? All right. So now we can go ahead and further simplify by multiplying like numbers. And the first term is going to be 16x to the 4th, because you have 1 times 2x to the 4th. When you distribute the 4 exponent to 2, 2 times 2 times 2 is 16. X to the 4th is 16, so that makes sense. Our second term, I'm not going to go through this step by step because it's just too much. It's too much to speak out. It would take up way too much of your time, and I'm pretty sure your time is loaded already. Our fourth term, and then the last term is obviously going to be y to the 4th when you multiply out the factors 1 times y to the 4th. All right, so this is pretty much it. This is our simplified or our expanded binomial. So 2x, or 2x minus y raised to 4, is equivalent to this expansion here. And this is great because if you have a polynomial that has an order that's greater than 2, it's pretty time consuming to go ahead and apply the distributive property to multiply everything out. So this is actually a quicker way to do that. All right, so lots of love and good luck studying.